Once again, hearty welcome to the Math Revision Made Meticulous video series. Topic: Application of derivatives. Derivative as a rate measure. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per video from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. Let us see what do you mean by derivative as a rate measure. The derivative of a function f of x or a dependent variable with regards to the independent variable can be used as a rate measure of the function or dependent variable per unit change in the independent variable. For example, if you differentiate f of x, you will get f dash of x. If you differentiate y, you will get dy by dx. The dy by dx represents the rate measure of y with respect to x. If you want to find dy by dx at x is equal to a, that is the value of the derivative at x is equal to a, it represents the rate of change of y with respect to x at x is equal to a. It tells you the rate of change at a particular point. So I think in lower class you already seen what do you mean by velocity. Velocity is the rate of change of distance with respect to time. Therefore, velocity, when you want to write it as a rate measure, it is ds by dt. Similarly, what is acceleration? It is a rate of change of velocity. Therefore, it is dv by dt. Already we are having v as ds by dt. Therefore, you have to differentiate the distance 2 times. Therefore, second derivative of the distance will give you the acceleration. For now, you are seeing here how derivative is used to get the velocity and acceleration. Now, let us see some rate of change of quantities which we will be coming across. dr by dt, it represents the rate of change of radius with respect to time, and dh by dt, it represents the rate of change of height with respect to time. dA by dr, be careful, it represents the rate of change of area with respect to radius. Similarly, suppose if you want to find dA by dt, it represents the rate of change of area with respect to time, and dV by dt will be rate of change of volume with respect to time, and ds by dt is rate of change of surface area with respect to time. When we are doing let us discuss the rate of change of quantities of some geometrical figures. First, let us take circle. For circle, circumference is 2 pi r. When you want to find the rate of change of circumference with respect to radius, it is dc by dr. Therefore, answer is 2 pi. But when you want to find the rate of change of circumference with respect to time, be careful. It is dc by dt is right hand side 2 pi into dt by r. Therefore, the answer will be dc by dt is equal to 2 pi into dr by dt. Both circumference and radius to be differentiated with respect to t. For example, when you take area, suppose if you want to find the rate of change of area with respect to radius, it is 2 pi r. But the rate of change of area with respect to time t is dA by dt is equal to 2 pi r into dr by dt. When you take a rectangle, the same thing. The rate of change of perimeter with respect to time is dp by dt, and area is dA by dt. No issue there. Or you can find now. There won't be any problem. Well, then rate of change of quantity with respect to cube, it is surface area 6x square. For ds by dt you can find, and similarly for volume you can find dv by dt. The answer is 12x into dx by dt is the rate of change of surface area. 3x square into dx by dt is the rate of change of volume. Then sometimes you should be careful with the sign of the rate of change of quantities. dy by dx is positive when y increases as x increases, and negative when y decreases as x increases. Now you are seeing here in the parabola dy by dx is negative, but there dy by dx is positive. Therefore, the area of the square is increasing at the rate of 5 cm given in the question. You have to take dA by dt is equal to 5. Suppose if they are telling area of the square is decreasing at the rate of 5 cm per minute, you have to take it as dA by dt as minus 5. Whenever in the question, read the question carefully. When they are telling it is increasing, take it as plus. If it is decreasing, then take the derivative as minus. Well, then you know what should be the marginal cost. The marginal cost MC is the instantaneous rate of change of total cost with respect to the number of items produced. In the exam, they will give you the number of items produced as a function. They will ask you what is the marginal cost, differentiate it. Similarly, total revenue they will give. How to get the marginal revenue, differentiate it. Marginal revenue is the instantaneous rate of change of total revenue with respect to the number of items. Whenever they want marginal cost or marginal revenue, differentiate the given function. Well, how to get the rate of change of quantities? Identify the function equation connecting the variables. List out the rate of change of variables given, and differentiate the function with respect to the variable for which the rate of change to be obtained, and substitute the given rate of change of variable to find out the required answer, and find out the rate of change for a particular value given you first. You have to first identify the function, then list out the rate of change of variable given. Some rate of change will be given in the question. Differentiate it, substitute it, and find the rate of change at a particular spot may be asked in the question. Let us go to question number 1. The side of a square sheet is increasing at the rate of 5 cm per minute. At what rate the area is increasing when the side is 10 cm long? Now let x be the side of the square, and dx by dt is given as 5. It is given as it is increasing, therefore you have to take it as 5 plus 5. And area is x square. I differentiate it, it will be 2x into dx by dt. Look out, it is differentiating with respect to t. Now dA by dt is 2x into 5 because dx by dt is given there. Therefore the rate of change of area is 10x. But they want what will happen when it is 10 centimeter. Therefore put x is equal to 10, you will get 100 centimeter square per minute. Therefore the rate of area is increasing at the rate of 100 centimeter per minute when the side is 10 centimeter long. Well, the volume of the ice cube is decreasing. Please note down, decreasing at the rate of 2 millimeter cube per second. At what rate is the edge is increasing? When the edge is 5 millimeter. Now x be the edge, and dV by dt, volume is decreasing, therefore I am taking it as minus 2. And volume is x cube, I am differentiating it with respect to t, 3x square dx by dt. What is given in the question? dV by dt is given, I am substituting, it is 3x minus 2 is equal to 3x square dx by dt. Now dx by dt is obtained as minus 2 by 3x square. This is a common formula to get the rate of change of h. But what they want? They want at 5. Therefore put 5. Therefore when x is equal to 5, dx by dt is 2 upon 3 into 25. Therefore the answer is minus 2 upon 75 millimeter square per second. For when you want to give the answer as decreasing, when you use the word decreasing, then you should not use the minus sign. It will be 2 by 75 millimeter square per second. Well, please see the difference. Dx by dt is minus 2 by 75. Whenever you are using the word decreasing, only 2 by 75. Next question. Sand is pouring from a pipe at the rate of 12 centimeter cube per second. The falling sand form a cone on the ground such a way that height of the cone is always 1/6 of the radius of the base. How fast is the height of the sand cone increasing when the height is 4 centimeter? Whenever you are involving problem with the cylinder and cone, be careful, because those formulae of either volume or surface area, they have more than one variable. Therefore clue will be given in the problem to express one variable in terms of the other. That should be very important. If sand is pouring, it is forming a cone. I call R as the radius, H as the height, and V as the volume. And what is given in the question? It is given that height of the cone is always 1/6 of the radius. Therefore height is 1 by 6 R. Therefore I am getting R is equal to 6H. R is equal to 6H. I am putting it in the formula. Before we go further, what is given? dV by dt. It is pouring, therefore it is increasing, therefore 12. Volume is 1 by 3 pi r square h. Therefore for r I am replacing it by 6h. Therefore I am getting the formula as 12 pi h cube. For I got a formula of volume in terms of a single variable. Now I will differentiate it with respect to t now. Therefore rate of change of volume is 12 pi into dh by dt of h cube, which is nothing but 3h square into dh by dt. Cross cancel it. It will be 36 pi h square into dh by dt. Now what is dh by dt now? It is 12 upon 36 pi h square. Now I got a formula for rate of change of height. Now they want what will happen if it is 4 centimeter. I am putting 4 there. Therefore it will become 1 by 48 pi. Therefore it is coming as plus. Therefore it is increasing. Height is of the cone is 4 centimeter. Height is increasing at the rate of 1 by 48 pi centimeter per second. Here rate of change of volume is given. You have found rate of change of height. Go to question number 4. The volume of a spherical balloon is increasing at the rate of 25 centimeter cube per second. Now we have to find the rate of change of surface area. Rate of change of volume given, rate of change of surface area is asked. Both are connected by the rate of change of radius. Well, let us see. Let R is the radius, B is the volume, and given that dV by dt is plus 25 because it is increasing, and volume at any time is 4 by 3 pi r cube. dV by dt I am finding, therefore dV by dt is nothing but 25. 25 is 4 by 3 pi 3 r square into dr by dt, for I am finding what is dr by dt. I got a formula for dr by dt, rate of change of radius. It is 25 upon 4 pi r square. Now I will go to the formula for S. The S is 4 pi r square. Therefore 4 pi into 2r into dr by dt when I differentiate. But I am having a formula for dr by dt. Answer for dr by dt. I am putting it directly. Pi getting cancelled. 4 getting cancelled. And you are getting 50 by r. This is the formula for the rate of change of surface area. But what they want what will happen the rate of change of surface area when the r is 5 centimeter. Therefore it is 10. You are getting plus 10. The surface area is increasing at the rate of 10 centimeter cube per second when the radius is 5 centimeter. Well, let us go to the question of marginal cost. The total cost in rupees is given as C of x is equal to a polynomial. Find the marginal cost when 17 units are produced. Already we have discussed what is the marginal cost is the rate of change of total cost with respect to output. For marginal cost is d by dx of C of x. For I am differentiating it, it will become x cube is 3x square, x square is 2x, and differentiation of 15x is 15. Now I am multiplying and keeping it ready. Now they want the marginal cost when 17 units are there. Therefore I am putting x is equal to 17. I am multiplying. Therefore I am getting the final answer as 20.769. Therefore when 17 units are produced, the marginal cost is rupees 20.769. Well, for success is dependent on efforts. All the best. Thank you, friends.